Thank you for the intro. And as Andy said, I'm going to talk about my journey, what I learned about test strategies and microservices. But I want to, before starting, talk about why I'm here. Like around 4 years ago, I was given a task. And it was, hey, Sam, we want you to come up with a test strategy that will guarantee that the decomposition of our monoliths into microservices in a multi-tenant fashion will be safe to our customers and transparent. And I was like, yeah, all right, easy. We have a really good test coverage. We have everything in our current state in order, so it will be easy. All I have to do is run our test in the target environment with some tricks, and it will work. But I was so wrong. And I wish I had somebody to tell me, you are so wrong. Don't go down that path. It won't work. That's why I'm here. I want to show you the mistakes I made and the things that I learned so that you guys can save some time. So I'll be talking about 5 groups of things. The first thing is a little bit of an overview of monoliths versus microservices. If you're here, you already know about it. But I'm also going to highlight the differences in behavior that these architectures drive in teams. The second thing I'm going to talk about is traditional testing models and how I was so wrong and why. Then how to actually put a different strategy in place that will work better, especially for integration testing. Then I will also talk about how the famous testing pyramid changes and how prevention becomes a bit less important. And being the first one that knows when things go wrong in production is even more important, and reacting fast to that. And then I'll talk a little bit more about safe rollouts. So monoliths and microservices. We've all seen this. Nothing new. So a monolithic application is generally built as a single unit. So the database, client-side, server-side, it's a single logical executable made out of different parts, but bundled together. And as a developer, you have to deploy a new version of the server-side application if you want to get a new version. This drives a team behavior of having large teams that work in a single code base or deliverable. And as a developer, from a code perspective, was available at any time, right? The code base is that monolith, and you know what you can use and you cannot use. By contrast, microservices are about disassembling that monolith and converting it into a set of independent services that are developed, deployed, and maintained independently. So that drives a team behavior of small groups of people that are responsible for small services that have small responsibilities. Integrations happen through REST APIs, and that becomes our, so to speak, common language, or English. So having said that, let's move into the traditional testing pyramid. We've all seen this. We're always told you must have a strong base of unit tests. You then have a strong base of component-to-component integration tests. And end-to-end tests are evil, right? That's something that we've learned. But how are each of these tests behaving in monoliths versus microservices? So let's do an analysis. In the monolith, let's start with end-to-end tests. They're slow. They are unreliable, or flaky, as we would like to call them. They are difficult to maintain because very little changes in the UI might make your test break. They're difficult to debug. An error that manifests in a UI test and an end-to-end test might be caused by many different things. So it's difficult to get to the root cause. And they test real end-to-end integrations by spinning up this one thing, which it's not that bad, right? You spin up one thing, you run your tests. In distributed systems, it's a bit different. Well, tests are still slow. They're even more unreliable because they start to depend in many bits and pieces, maybe many moving pieces. They're still difficult to maintain. They're still difficult to debug. And to test the whole integration, you need to spin up n services, whatever you want to test, whatever integration you want to test. So it's not one thing, it's several things, right? So that's when all the problems come from. Let's move into unit and integration tests. In the monolith, they're fast, they're reliable, they are easy to maintain, they're easy to debug, but they do not test the real integrations. And they are based in assumptions. Assumptions that are made at a specific point in time when you develop that test. And I'm talking about mocking, right? Mocking responses. So put a pin on that. Let's move to integration and unit tests in distributed systems. They're not that fast when you're talking about integrations. Again, you have many moving pieces. They start to become a bit less unreliable. They're still easy to maintain and debug. But now you're required to mock more moving pieces, and still based on assumptions. So what if your assumptions change? Which, by the way, in distributed systems is more likely, right? Because remember, we just said that we want to move fast, smaller teams, and independently. So it's very likely that that team that is in the other side of the world is going to make a change that changes my assumptions. So I always like to tell the story of this Friday. I was going out of the office, happy, planning to have some drinks with my friends to celebrate that I survived another week. And PagerDuty, here it is. Our friend PagerDuty. I see a lot of smiles here. You're friends with PagerDuty, just like I was. I was paged because a service that I didn't touch in 3 days was down. And I was like, hold on a second. I haven't released anything in the last 3 days, and this is reporting to be broken. How come? How did that happen? And I was, in first person, a victim of the, you build it, you run it, they break it, you're paged, right? Nobody told us that would happen. And it happened. So in this new world, the only way that we had at that time to detect these failures was to have developers watch for those changes. How good is this? Yeah, go and just watch every single developer that is making changes to a different code base that you're not responsible for. This is not realistic, right? It's not realistic for big companies that have 2,000 developers committing every day to different code bases. It's not realistic for my current company, CloudBees. We're working 24 hours, so we're a distributed company, just like NGINX, and we have developers from New Zealand to the West Coast going through Europe. It's just not realistic. So we needed something that allowed us to develop independently, going fast, without breaking things, and without needing to watch every single change that is going around in the company. What if we could get the best of both worlds? The end-to-end testing, but in a fast, reliable, easy to debug, and easy to maintain fashion. Well, I have good news. That's possible. So it's possible through consumer-driven contract testing. We used Pact because it was a framework that we knew at the time. It's a framework developed by an Australian group, and I happened to be living in Australia at that time, so it was easy for me to talk to them and get to understand their framework. But it's basically based on the fact that the center are the integrations between different services. You're going to have a provider of an API, and you're going to have an ecosystem of consumers that are going to consume that API in different ways. So it's all about writing tests. The way it works is, you write tests in your consumer side. So I have an example of a phone book application. So you have the consumer, you have the provider, and the consumer, given a name, wants to get the phone number, right? Easy, simple. So the way it works is that you will write in the consumer side, you would say, OK, this is the way that I'm going to use your API provider. And you will write unit tests, like normal unit tests. But you will run it against a mock server, which is a special mock server in this framework. And you will assert your assumptions and write your assumptions just like a normal unit test. But the good thing is that this is a mock server. So it's not a mock. No wiring needed to pretend that you're talking to a service. It's real HTTP interactions. When the tests are run, the mock service returns the expected responses, just like unit tests. And there's a file that is generated, the pack file, which is just a JSON file, and that represents all these requests and all the expected responses. So it's just recording the requests and the responses. And then what happens after that? That's established as the contract between the consumer and the provider. And then on a change basis in the provider, they will have to run through those contract interactions twice. They will just go and run with their changes and say, this is what I'm returning, and then compare it to what's in the packed file. This is what you're expecting me to return. So all of a sudden, we're having like end-to-end tests without really needing to spin up both of them at the same time. So you just split it, and you're doing it in isolation. So let's see an example. I think it's easier to see it with an example. I was talking about the mom, right? So on the consumer side, in the left, we have the HTTP request get phone number mom, and the expected response is the phone number, 604-123-123. That's not my mom's phone number, so don't try to call her. On the provider side, that's a really simple Spring Boot application. So it's really a hash map that contains a mapping between the name and the phone number. And it will return on the /name endpoint that phone number that corresponds to the name. Easy, right? So this is how it works, and this is how the contract packed file looks like. So you get a description of the interaction, the method, the path, the response type, status, the headers, the body, everything. And packed allows you to not only assert on the body response, but anything. Headers, content type, matchers, anything you want, right? So this is a very simple example with a number, but you could get really anything you want. But how do we see it not working? How do we handle breakages? So let's say that I am the provider, the owner of this service, and I say, look, I just realized that we not only have local friends, right? My mom lives in the same country I do, Spain, but generally you have friends abroad. And for that, you need to store the country code. So let's add a new feature that is going to actually add the plus and country code in front of the phone number. Let's do that. What would happen if we do that? Well, we're just changing the contract, right? Because the consumer was expecting a string of a certain length and was asserting for that. But then I'm changing it, and I'm putting a plus 34 in front of it. When will it break? It will break on the provider change. The consumer will never know that that's broken. So now, as a provider, I have two options. There are two alternatives. I did the change by mistake, so this is a bug, and I just prevented, an outage in production, which is nice, I think. And if the change is happening on purpose, then I realize I need to talk to the consumer so that they change their expectations. They change their contract. They change their APIs to consume this new feature that I'm putting in place. So what are we doing? We're making humans talk. We're just putting them together so that they do what they're supposed to do, but it's difficult for us. We're not solving a technical issue here. We're solving a human problem here about communication, which is a challenge, especially in distributed companies and distributed systems. So what do you need to make consumer-driven contract testing work? You need consumers to clearly state their contracts. What is your expectation? The sooner you do it, the better. Generally, it's better when you're going to start to use an API. Go talk to the provider and say, hey, this is how I'm going to use your API. This is what I need. This is our contract. Do you agree or not? Secondly, we need communication. So that can only happen if you talk to people. And the third thing is red is red. If you're the provider and you see that some builds are red, you need to ask yourself if you've broken something. You cannot really overrule it, but that's basics for every single test, right? Sorry. What does consumer-driven contract testing give you at this point? Fast feedback in isolation. If I don't want to, once I establish the contract, I don't need to talk to anybody if things go right. If things go wrong, I have really fast feedback. It's early detection. So if I break something, I'm going to know the earliest possible. I'm not going to get into any testing environment. I'm not going to get into staging. No customer is going to see this. This is the earliest possible that you can get it. And if things go wrong, it's going to bring people together to discuss what are the next steps. Should you change your contract? Should I kind of, revert the change? So it's all about this. So this is how we solve the end-to-end integration testing. And that is what made us rely even less on end-to-end tests and rely a bit more in this kind of consumer-driven contract tests, which are in the base of the pyramid. But we realized that even though you put a lot of safety nets in place and you have prevention in your mind, which is really important, we realized that in distributed systems it's also a priority to be the first one to know when things go wrong in production. You don't want to know from Twitter that your site is down. It happens, but that's not nice. It's not a sweet spot to be in. So detection and fast reaction become important. And that's why post-deployment verification is also important. You want to know if your application is alive after a deployment and over time, so health checks become really important. And monitoring. A lot of people say monitoring is the new testing. I have a background of quality engineering for more than 10 years, leading teams. Prevention is in my DNA. But we need to understand how we expect our applications to behave in production. Understand what's expected and what's not. For example, number of 500 responses per second. If that goes up, somebody did something wrong somewhere, and you should be investigating. Establish those thresholds and change them over time if you learn something new about your application. Measure, monitor, raise alerts, and react. But again, I have a quality engineering DNA, so I kind of say just go do it in production. You can train internally, right? You can have different test environments. You can have service development. We're shifting things to the left, where you have your smoke tests, your contract tests, unit and integration, and then you deploy into a real environment together with all these little bits and pieces, and then you put monitoring in place. Monitoring is not only for production. You can learn a lot about your internal traffic. You can put synthetic transactions in place so that you can actually predict and extrapolate. So it's not only about production. I am not saying that. And that's why the title of this keynote is When the Pyramid Becomes an Hourglass. Because even though we put a lot of prevention in place, things happen. And we need to be the first ones to know and react fast. And in order to do that, you need to have some testing in production and monitoring to understand how your app is behaving. But yeah, quality engineering background. That made me think, well, this looks good. But by the time you react to your alerts, your customers are already screwed, right? So I thought, well, how can we do it so that when things go wrong in production, we affect the smallest number of customers possible? So there are some ideas here about safe rollouts and how that saved us from a couple of bad experiences. So the first one is feature flags. You need to be ready for feature flags. You need to change the way you develop to accommodate feature flags. Feature flags are about being able to make a configuration change to turn on and off your features. What that gives you in production is the ability to, if something is broken or misbehaving, you just turn it off, as it didn't happen. It protects customers from malfunctions. But again, it's a cultural change. You need to put the effort up front to be able to then do that configuration change in production and enable and disable, which is the beauty of it, right? You don't need to go through an entire release process to enable or disable this feature. It turns on and off through configuration. That's one way of reducing the surface area of people that gets affected by issues. The second one is canary rollouts. You can decide to just deliver your changes to a small, or your features to a small set of your customers. You can pick and choose them by interest, randomly, internally. But the idea is that you deploy to that group, and you have access and measure how they behave. And you can then decide if you move forward with the rest of the customers, or if you stick to where you are. And then continue increasing, or even revert if things are going really wrong. But what really gave us a lot of insightful information was dogfooding. So dogfooding is nothing else than using your own products before they go to production internally. We do that at CloudBees, right? We recognize that testing is synthetic. We use our CI/CD tools internally to build our products, to work, to test. So we are very representative to our customers in one hand. And in the other hand, we have a really big incentive to get things right from the beginning, because if we break our internal environments, we're stuck. We're really blocked, just like our customers would be. So two things that dogfooding has a lot of value for are, first, catching big issues that only represent a load, or big issues that for some reason you skipped in testing, but that doesn't happen that frequently. And the other thing is UX, usability, and new features, kind of corridor tests, right? If your internal people, if they don't know how to use your feature, if they don't understand what it is about, if they don't like it, and you're so representative of your customers, why would you move ahead with that, right? So it gives us an idea of how hot our features will be when they, reach our customers. So what did we learn in this whole journey? Well, the first one is, in distributed systems, integrations between services, between consumers and providers, are the key thing, right? And it's very important to have strong contracts defined between the consumers and the providers, even before you start coding. So that's first lesson learned. Second one, if something goes wrong, you want to be the first one to know. And you want to be able to react fast. And the third one is, as I said, when things go wrong, you have already affected your customers. So you want to reduce the surface of customers that get affected by your changes by doing safe rollouts and practicing dogfooding internally. So that's my story, that's my journey, and I hope it was helpful for you guys. Thank you.
Thank you. That was fantastic. I think we saw from our user survey earlier that about 40% of this audience is either dealing with some sort of monolith that's just beginning to break down, or they're all the way into microservices. So I think it was really helpful to see what some of the testing capabilities and that the collaboration, what all that looks like. So appreciate you sharing that content. I want to step back for 1 second. I'm just going to ask a few questions before we sort of bring up the next speaker. So you mentioned you've done this at several different journeys now, helping break monoliths down to microservices. What was the genesis for even doing that? What was it at each stop that even had you say, OK, microservices is the right answer for our company?
So in different companies, I think they had a different reasoning behind, but I think the key thing is that it allows you to go fast, which I think enables experiments. So I think it's easier to experiment where you can just spend a week and building something really small. If it doesn't work, you just tear it down. So I think it's the key thing to experimentation and going really fast. So that's, I think, one of the key things that all the companies had in common. Like, we really want to move faster than we're moving right now. And we also want to experiment and make sure that, what we're building makes sense. And if it doesn't make sense, do not really invest a lot of time in it. So that's probably the common factor for all these companies.
OK. Do you think you're ever going to go back to monoliths, or do you like microservices?
I don't know. I mean, this is cyclic, right? So you never know. I might be here saying in stage that, yeah, this is the future. And then 2 years later, I might be saying, oh, we realize that it's not. But I think it serves its purpose. And I think different companies have different needs. So for the ones that want to go really fast, if you have the right safety nets in place, because we see there are a lot of trade-offs, it's a really good path to go down and explore. Definitely, yes.
OK. Just a few more questions come to mind. So one is, so obviously you're in a much bigger distributed system now when you inherently go to microservices. You've focused on the testing side. What are some of the other challenges you've seen in your career as you go to a distributed systems kind of architecture?
Believe it or not, it's all about communication. Like, I'm an engineer, and I find it difficult sometimes to talk face-to-face to somebody that is sitting next to me. And I use Slack. I don't know why, right? It would be easier to just talk to that person face-to-face. And if you extrapolate that to distributed organizations or big corporations, it becomes even worse. So I think the biggest issues we're always trying to solve are communication issues between people that do not know what's happening in that side of the organization, and they don't know that they're getting a change that is going to impact them. And in distributed systems, this is very noticeable because of the nature of the architecture.
Yeah, that's excellent. Yeah, we have a lot of companies that as they're rolling through Silicon Valley, which is where NGINX is based in San Francisco, they ask, maybe it's a big traditional enterprise, how do you guys succeed in this big distributed organization? Got to kind of focus on the communication.
Yeah, there's also another problem, and it's ownership. So when you kind of cut in little pieces all the functionality of your services, of your products, then you end up in a situation where nobody owns this landing page here, because it's made out of so many small pieces that nobody has a holistic ownership. So that's another problem, and you need to recognize that that's happening and assign owners for that. But that's another big challenge together with communication that I think we experienced.
OK, great. So I guess one last question. We about a third of this audience here comes from application development or is in some way, shape, or form walks a mile in your shoes. You talked a lot about the traditional pyramid, and at the bottom is kind of API unit testing. Does the consumer-driven contract testing, does that end up replacing these things? Do they end up complementing, supplementing? What kind of advice can you give to folks?
So absolutely not. So it's not a substitute for that. Like, I was focusing on integrations, but your service still has to perform, right? And has to be up and running, independently of who it talks to. So it's not a substitute. It's more a substitute for end-to-end testing, I would say. Or, yeah, it's a better way of doing it in a faster fashion and more reliable. But unit and integration, like component-to-component tests, are still there. So you need to extensively test your service to make sure that it behaves as expected, as you define it, because you offer functionality that not all the consumers are going to use. So that's also the beauty of consumer-driven contract testing. Like, if I use only this endpoint, I'm going to only take care of this endpoint. So you could be breaking other consumers, but not me. But overall, you need to keep your endpoints up and running and behaving as expected. So it's not a substitute. It's an addition to it.
Great. All right, well, thank you so much. I know you came all the way from Spain to join us, and you'll be around the rest of the day. So if folks have questions, please find Isa at lunch. But we really appreciate you coming all this way and taking the time to join us at Conf.
Thank you, my pleasure.
Right, thank you.
Thanks.